Hello, my dear students. Welcome to my YouTube channel Physics Words. So, in this video lecture, I'm going to discuss some of the problems related to WBSET 2023. We have already discussed some of the problems previously, as you can see in my channel. So, let's do some more. So, the question number 88, it's a very basic classical mechanics problem. And it's a problem of canonical transformation, as you can see. So in this question, a canonical transformation is given, and as you can see, this small q small p, these small q small p are the old sets of variables. As you know, in the canonical transformation, what we are doing some transformation from old set of variables, that is qp, these are my old sets of variables, to the new one, which is capital Q and capital P. And in this process, the transformation is done in such a way that Hamiltonian remains invariant. So in this process, the Hamiltonian remains invariant, and these are my old set, and this is my new set, and the Hamiltonian remains invariant. So if you suppose that old set Hamiltonian is capital H and the new set Hamiltonian is capital K, then we know the old set Hamiltonian and the new set Hamiltonian is related by the equation K equal to H plus del F by del T, where F is the generating function. These are the very basic things you must know about the canonical transformation. Okay, and there are of course four forms, F1, F2, F3, F4. These are very old, these are very basic things, and you study these things from your BSc courses up to your MSc courses. So F1 is a function of capital Q, small q and t. F2 is a function of capital P, small q and t. F3 is a function of small p, capital Q and t. And F4 is a function of small p, capital P and t. So in this question, this is given that q equal to q square, that is capital Q equal to q square, and capital P is capital P is what? Capital P is small p divided by 2q, as you can see. So the time dependent, they are asking the time independent generating function. So what is the time independent generating function? And four options are there, as you can see, and the four options are given as capital P and small q. So capital P and small q is F2. As you can see, capital P and small q are F2. And what are the equation of motion corresponding to F2? For F2, the equations of motions are small p is equals to del F2 divided by del small q, and capital Q equal to del F2 by del capital P. Okay, so from here you can get F2 is equals to integral small p in dq, and small p is what? Small p is, as you can see, small p is 2q capital P. Okay, just substitute these values over here. You can get 2q capital P into dq. Since the integration is about dq, so capital P will comes out and it will be 2q dq, and from here you can get The q square p is your answer. And similarly, the other equation from here, you can also get the solution. From here also you can get the similar result, q square into p. How? Let me check. f2 is how much? Q integral of dp. Just substitute q as q square. Just substitute q as small q square into dp. So it will be, the integration is about p, so it will be q square into p. So the same result you will obtain. So definitely the answer is option number B. So definitely this answer is option number B is the right answer. Okay. So it's a pretty simple problem, but very interesting problem. Okay. So let's do another problem. The problem which I am going to show you is the problem on statistical mechanics. Yes, number 74. A polymer chain composed of 1000 molecules, infinitesimally small, held by intermolecular links of length d each. So there are polymer chain. So it is number 74. So there is a polymer chain which consists of, so let's say these are my chain, these are my elements. So there are 1000 of them, and the length of the each chain is d. Length of the each chain is d. Okay. So the angle between two consecutive links can only be 0 or 180 with equal probability. So the consecutive links can be either parallel to each other. So the links can be either this way. This is the parallel arrangement where this angle theta equal to 0 degree, or they can be anti-parallel to each other. So this is the arrangement. Okay. So there are n equal to 1000 number of molecules are there, and the links can be either parallel to each other or anti-parallel to each other. So in the parallel arrangement, let's suppose your energy will be minus epsilon, and in the anti-parallel arrangement the energy will be plus epsilon. So, and because in the anti-parallel arrangement the energy required will be definitely greater than the parallel arrangement. So in the parallel arrangement the energy should be minimum, so that's why it's minus epsilon, and this is plus epsilon. Okay. So if the length of the polymer is 100d, what is the number of possible microstates? So it is given that the length of the polymer is 100d. So let's suppose there are n1 number of links which are in the parallel arrangement, and there are of course n2 number of links which are in anti-parallel to each other, anti-parallel arrangement, so that n1 plus n2 will be definitely your 1000. That is the capital N. So how many number of microstates are there? So if there are capital N number of links, and if there are n1 number of links which are parallel to each other, and if there are n2 number of links which are anti-parallel to each other, so definitely your number of microstates sig omega will be n factorial divided by n1 factorial n2 factorial. But again, n1 and n2 is not known. N is known, but n1 and n2 is not known yet. So in order to get the values of n1 and n2, we get another equation. So this is my equation number 1, of course, but we have to get another equation. Okay. So another equation is, let's say since P1 and P2 are both at equal probability, since in the question it is given that probability of finding these parallel and anti-parallel arrangements are same, so this will be half. P1 and P2 is half. Okay. So now it is given that the length of the polymer is 100d. So what is the length of the polymer? Length of the polymer is nothing but, that is the number of parallel arrangement multiplied by probability of finding each parallel arrangement, that multiplied by the energy that multiplied by this epsilon. Okay, just wait. No, that multiplied by d, because d is the length of the each chain, and plus n2. So it is not plus, it will be minus, because in the anti-parallel arrangement it will be minus d. So it will be simply minus n2 p2 d, that should be equal to 100 d. So how do you get it? Because n1 p1 d, this is what? This is the length of the links which are in parallel arrangement, and this is the length of the link which are anti-parallel to link. So that total length will be parallel minus anti-parallel. Okay, so since p1 and p2 both are half, so n1 d by 2 minus n2 d by 2, this should be 100 and d. So from here we get n1 minus n2 is simply 200. So from these two equations, so this is my equation number 2. So combining this 1 and 2, we will get, if we add them up, 1 plus 2, if we simply add them up, then 2n1 will be 1200 and n1 is equals to 600, and from here n2 is my 400. n2 is my 400. So now you get the values of n1 and n2. Now you will easily find out the number of microstate. So number of microstate will be 100 factorial divided by 400 factorial 600 factorial. So it is definitely option number D is the right answer. So the correct option is option number D. Okay. So okay, that's it for today. So in the next video lecture, I am going to discuss some more problems. Thanks for watching.